Here we go. Your last difference quotient problem says find and simplify the difference quotient for each of the following functions. Y equals 5 over x. So on your test, I won't give you anything that we've not done in class. I could give you linear. I could give you linear, I could give you quadratic, I could give you a radical function, or I could give you a rational function, which is here, 5 over x, because rational. The reason we call this a rational function is because it looks like a fraction. So again, instead of f of x, we have y. Y and f of x interchangeable, means the same thing. So here we have f of x plus h, which is 5 over x plus h. Again, to find f of x plus h, take out the x, put in the x plus h. Your formula is f of x plus h minus f of x, which is the original function, all over h. That is the answer before we clean it up. In order to clean this up, let's find the common denominator on top, which is I need an x here, and I need an x plus h here. So we now have same bottoms on each of them. Any questions about how I did that? A lot of people are tempted to somehow add h over here so the bottoms are the same. You can't do it. Okay, if it makes you feel better, put them both in parentheses. Two individual things, we need both of those things on the bottom. Again, if you do it right, we should have a lot canceling here. On top we have 5x. This minus goes with this 5, so make sure as you distribute this 5, you distribute the negative with it. So negative 5 times x and negative 5 times h. Cancels. In order to divide, we flip and multiply, so I'm going to save myself a step. I'm going to come out here, I'm going to mark this out. To divide by h over 1, I'm going to multiply by 1 over h. Again, these are already gone. My h's now will also cancel. And it leaves me with negative 5 over x times x plus h. That is the difference quotient. That's the cleaned up version of the difference quotient. I do want to go the step further. Difference quotient is an average rate of change. Reminder from yesterday, x would be a starting x, h would be the distance between your h's. So if you took 2 points on here, if you want to say, what is your average rate of change from x equals 2 to x equals 5? All you'd have to do from 2 to 5, you would put a 2 for x's, and you'd put actually a 3 for the h's. Okay, because h is the distance from one x to the other x. But what I want you to do, just to get ourselves ready for after Christmas, instead of just doing the average rate of change, let's go ahead and do the instantaneous rate of change. So this is my first answer. There's my second answer. All right, that's all you got to do. Take out the h, put in a 0. So your actual derivative here would be negative 5 over x squared. Average rate of change, instantaneous rate of change. So if you want to know what's the instantaneous rate of change at the point 5, 1, you just put a 5 there. Plug in that x. Okay. Next objective, students will graph functions, including piecewise function, using graph paper and graphing calculators. They will also find the domain and range of relations. In addition, they will determine where the function is increasing, decreasing, and constant. So pretty much we're studying functions now. We've been studying functions, but now we're looking at their graphs, what they're going to look like. First off, how to graph with a table. Folks, anything can be graphed with a table, with a t-table. When you do a t-table, you have inputs and you have outputs, x's and y's, or it could be a's and b's, it could be r's and s's. It doesn't matter really what the letters are. Pick anything you want to for your x's, plug them in, and you get your y's. You can pick anything you want to for your y's. If you want to work it backwards, pick all your y's, plug those in, and find your x's. It doesn't really matter what order you go in. Y equals x squared. state the domain and range, determine whether the relation is a function. So we're going to do a little bit of all. X, y. We're graphing the function y equals x squared. You've done this before, right? Plug in 0. You get 0 squared, which is 0. Plug in 1, you get 1 squared, which is 1. Plug in 2, you get 2 squared, which is 4. Don't forget to plug in your negative values as well. Plug in -1 squared gives you a +1. Let me caution you on something. If you type that into your graphing calculator, a lot of people type it in like this. They'll do -1 squared. And they hit enter and they get -1, which is wrong. Okay? -1 squared is not -1. Make sure if you are typing in -1 squared, the whole x, not just part of the x, but the whole x is being squared. It's -1 times -1. So if you're typing in a negative squared, make sure that you put it in parentheses. -1 squared is actually +1. We already knew that. -2 squared, -2 times -2 is 4. These are points. These are inputs and outputs. On your graph, your inputs go here, your outputs go here. Bet you've never thought of it like this. But actually when you're graphing, remember back in 2nd, 3rd grade you did bar graphs? Guys, this is just like a bar graph. On your bar graphs, your inputs were, okay, let's say we're doing a bar graph of the whole class's favorite color. And we have red, blue, green. Those were your inputs, right? Those were the things that you put on your x-axis. Your outputs were how many people liked each color. So the same way that you graphed back in 2nd and 3rd grade, you're doing the same here. Your input is 0, your output, you go up 0. Nobody liked that color. Your input is 1, your output is 1. Your input is 2, your output is 1, 2, 3, 4. Your input is -1, your output is 1. Your input is -2, and your output is +4. There's the graph of y equals x squared, and we knew it was going to be a problem. Says state the domain and range. The domain here, anything that you can plug in. Is there any this thing keeps going, right? Is there any restrictions on what I can plug in for x? What do you think, Savannah? Is there anything I can't plug in to x squared? Your domain, folks, is all real numbers. All things from negative. You can think of it like that, or you can think of where is your graph located? Everywhere. This thing keeps going all the way to the left, keeps going, all the way to the right, keeps going. Your domain is all real numbers. Your range is not. Your range is located here. Your range is your output. Your range or your y values will never be what? Negative. Your range starts at 0. Your graph starts here and goes up, correct? Your range tells how high or low your graph goes. Your domain tells how far to the left or right your graph goes. So here, make sure you put it in brackets. It's all the way from 0 up, 0 to infinity. There's domain range. And then, is this relation a function? This is just for review purposes. Is there anything that I could plug in for x that I'm going to get multiple y's for? Or is there any x value that has a point above a point? No. This is a function. Yes. There's your domain range. There's your t-table, and it is a function. Next one, we're going to graph y equals the square root of x the same way. But let's do something a little bit different. Guys, I don't do t-tables. The way that I graph this is, again, these are my inputs. These are my outputs. I'm going to input my x's, output my y's. Be cautious on what you do put in. Okay? Well, first off, here I can't put in negatives. I'm going to put stuff in here that I know the square root of. Okay? It's just, it works out nice, much neater. First number, Colby, that I know the square root of. Give me one. 9. I know the square root of 9. So I'm going to input 1, 2, 3, 4, 5, 6, 7, 8, 9. It's right here. When you input 9, you output what? Anybody? 1, 2, 3. If you don't want to make a t-table, don't. Okay, because you can plot those points. Give me, Jordan, another one. She's not here. Skyla, give me another one that I can input on that one pretty easy. Square root of 4, and here's your input, 1, 2, 3, 4. When I input 4, I get 2. When I put in, give me another one, anybody. When I put in 1, I get 1. When I put in 0, I get 0. Connect the dots. I do want to point out that this is what's called the principal root. Because when the square root of 4 is not 2 and negative 2. If you don't have the plus minus out front, it just wants the positive. So therefore, does that make this a function? Yes. If it had the plus or minus out front, would that be a function? No. Because then you have 4 is 2 or negative 2. Which, let me just show you there. If you did the plus or minus, this is not part of the graph, but if you did do the plus or minus, do y'all realize what a square root function is? It's a parabola on its side. Now somebody explain to me why it's a parabola. You're exactly right. This is quadratic. Take the square root, move it to the other side. How do you do it? Don't you square? Instead of y equals x squared, it's x equals y squared. That is a parabola. Okay? But we're only doing principal roots, or we're only doing the top part. So is it a function? Yes. The domain, and we're only doing the red one, ignore the blue. The domain is all the things that I can plug in for x. I cannot plug in negatives. I can plug in 0. So your domain is all the stuff from 0 up. Your range is what you'll get as an answer, which is the exact same thing. My graph never goes below this line. It starts at 0 and it goes up forever. Plug in 1,000,000. If you don't believe me, plug in 10,000,000. 100 trillion. If it'll fit on your calculator. You can trust me, I promise. Now x equals y squared. Let's do this one a little bit different. To graph x equals y squared, don't plug in x's, plug in y's. Follow me? Why? Because it's just going to be easier. Let's plug in y equals 0. When y equals 0, what does x equal? Good. Careful here though, when y equals 1, this is your y-axis. When y equals 1, that's up here. When y equals 1, what does x equal? Good. 1. When y equals 2, what does x equal? Can I plug in negative y's? Sure. Negative 2, when y is negative 2, x is 1, 2, 3, 4. When y is negative 1, x is positive 1. Guys, it's the same graph except for it's both pieces. X equals y squared. If you move a square to the other side, you do have to do plus and minus the square root. So that is actually the exact same function as before, but instead of just the positive square root, it is also the negative square root along with it. Is that a function? No. Why is it not a function? Put in 4 for x. If x is 4, y could be positive 2 or y could be negative 2. Each input would have at least 2 outputs, or actually exactly 2 outputs, except for the 0. It wouldn't. So that would not be a function. Domain, you can only plug in things from 0 up. Now range, a little bit different on this. It goes, where does the graph start down here? I don't know, it keeps going down forever. So from negative infinity is where it starts, and it goes up. Well, there's no top. So the range is actually negative to positive infinity. Now here's your cheat. Let's say that your college professor, if you want to write this down, your college professor makes you make a t-table. You're having to graph y equals, I don't know, let's make up one. Y equals x squared, let's try that again, x squared plus 5x plus 6. And instead of just graphing it, instead of just plugging in 0 in your head, plugging in -1 in your head, and finding it on your graph, your college professor makes you make a t-table. Guys, on this graphing calculator, let me zoom in and let you see this. Right above graph, it says table. You see that? So if you'd like to, you can do second table. Look, it does it for you. There's your t-table. When you plug in 0, you get 6. When you plug in 1, you get 12. When you plug in 2, you get 20. When you plug in 3, you get 30, and so on and so forth. What about the negatives? They're up here. You have -3, 0, and -2, 0, which would be your x-intercepts as well. But what if your professor makes you plug in weird stuff like 1.3 and all that? Well, change your table settings. Above Windows, you have Table Set. Table set is, okay, here's where I want my table to start, and delta, remember what I told you delta means, there's that triangle again. Delta table is how much you want it to change each time. Let's say I wanted it to start at 0, and I want it to go up by 0.1 each time. And when you go to your table, it starts at 0, and then you have 0.1, 0.2, 0.3, 0.4. Or here's how I actually do it. I go to table set, and on independent variable, this is pretty cool. You can click on ask. If you've got a bunch of, this is a good ACT tip. If you've got a bunch of stuff you need to plug in, type it into y equals, there's my function. Go to table set, set your independent variable, which is your x, your input, to ask, and then go to your table, and there's nothing there. Why is there nothing there? Anybody know? It's asking you. Okay, that's what ask means. It's asking you what numbers do you want there. I want to plug in 5.1, enter, and it plugs it in for you. I want to plug in 2.1596, enter, it plugs it in for you. Okay, that's really nice if you've got a lot of stuff that you need to plug in. Okay, moving on. Graphing calculators. Now that we're on the subject, y equals x to the third. Excuse me. On your graphing calculator, if you want to clear everything, be cautious of this. On the day of the ACT, if you show up and you got some programs stored, don't do what I'm about to do. Because not only will it clear what's in, like stored in A, B, and C, but it also clears your programs. Second, memory, reset, which is 7, all RAM, which is 1, reset 2. So it's second memory 712, and it clears your RAM, wipes everything out. Why is that handy? Because if your calculator is not working, or your graphs is giving you errors, or something, that's what I always do. Anytime I get an error message on my calculator, I reset my RAM. I reset everything. But again, it wipes every program out completely. Graph each equation. Go to y equals. We're graphing x to the third, so I type in x caret. It's right here above the divided by, so there's x to the third. Graph. Done. If you do want to change your window, let's see, and this is where that domain stuff comes in handy. I want my domain restricted. I want to change my window just because, look, this is wasted space. There is absolutely no graph here. There's absolutely no graph here. The graph on my screen goes from like -3 to +3. So what I'm going to do, I'm going to go to my window. You have Xmin and Xmax. And I'm just going to run my X's from -4 to +4. That's the only ones I want them to show. That way you see a better graph. Actually, -3 to +3 would have been even better. -3 up to 3. So it zooms in a little bit, I guess you could say. Tell you what everything on the window does. Xmin and Xmax, I just showed you. X scale, that's what you want each tick mark to be. Your scale here, this box is 1, 2, 3. Each tick mark is 1. That's what the scale means. Y min and max, that's how high or low you want your window to go. Y scale is the exact same thing. X resolution or X res, I have no idea what that is. Okay. So sketch the graph, state the domain and range. Your graph looks something like this. Guys, it kept going up and down. The domain, you have absolutely no domain restrictions here. X can be anything. So your domain will be from -infinity to +infinity. The range, it keeps going down, it keeps going up. It'll also be all real numbers or -infinity to +infinity. y equals x to the third will look very similar. Or excuse me, the cube root of x. Now, there might be a better way to type this in, but let's use our skills that we know. To type in the cube root of x, reminder, the cube root of x is x to the 1/3 power. Type it in like that instead of looking for a cube root button. The bottom number is the radical, the top number is the power. The cube root of x is x to the 1/3 power, so to graph that, just don't do this. That's wrong. Look what you get there, a line. Why in the world is that a line? Can anybody explain to me? Yeah, it's all over 3. I did x to the first power, which is x, and divided by 3. So I graphed x divided by 3 here. You want to do x all to the 1/3 power. So there's an insert key above delete there. So I want to insert a parentheses around that. X to the 1/3 power looks like this. My window, though, is set to what it was before. If you want to reset your window, you can go zoom, standard. Go back to your standard zoom, and now it's -10 to +10 on the x's, -10 to +10 on the y's. Guys, that is the exact same graph as x to the third. It's just rotated. Domain, it'll go forever. There is absolutely, you can find the cube root of anything. There is absolutely no domain restriction, so your domain is negative to positive infinity. This graph continues upward and continues downward, so therefore the range is also negative to positive infinity. Sketch the graph of this function, state the domain and range. Before we even start, are there going to be restrictions here? Domain? What do you think? Square root? Yeah. You cannot take the square root of a negative. Let me show you the old way of working this. We can use our calculator, our graphing calculator to do it, but let me show you the old way of working this. The stuff under the radical cannot be negative. The stuff under the radical, which is 9 minus x squared, has to be greater than or equal to 0. So anytime you're asked for just domain, if you're dealing with a radical, take the stuff underneath, set it greater than or equal to 0. That'll tell you the things that x can be. That'll tell you the x values that you can plug in. This is simply finding the domain. And I'm going to clean this up a little bit. I'm actually going to take negative x squared and move it over here. And then I'm going to flip-flop this whole thing around. X squared is less than or equal to 9. And honestly, hopefully you can look at that and tell what things x can be. Can x be 3? Is 3 squared less than or equal to 9? Sure. What about 4? 4 squared to be bigger, right? So not 4. What about 2, 1, 0? Legal. So we can plug in 3, 2, 1, 0, -1, sure. -2, -3, yes. But when you go get past -3 and you start trying -4, it's too big again. So here's what your domain is actually going to be. The domain is going to be all things from -3 to +3. This is how we used to do it. When you plug in things from -3 to +3, what do you get? Plug in -3. 9 minus 9, you get 0. Plug in -2, you get 9 minus 4, which is 5. Plug in -1, you get 9 minus 8, which is, hang on, did I do that right? Plug in -1, you get 9 minus 1, which is 8. I said that backwards. Plug in 0, you get 9 minus 0, which is 9. And then look what happens. Plug in 1, you get 9 minus 1. It goes backwards again. So what is my range? It looks to be all the things from 0 up to 9. So here's domain, here's range. That's doing it by hand. Do I have to do it by hand anymore? No. Do it with a graphing calculator. The square root of 9 minus x squared. Graph. Looks to be half of an ellipse there, or half of an oval. It's actually half of a circle. So why does it look like half of an oval? Because this graph is not perfectly square, to be honest with you. It all has to do with it's skewed because this graph is wider than it is tall. If the graphing calculator screen was actually square, it would look more like a circle. So why is that a circle? Watch this. Take square and move it over there. You get y squared equals 9 minus x squared. Take x squared and move it over there. It gives you x squared plus y squared equals 9. Is that not a circle? That's a circle with a radius of 3. So why did we not get the whole circle? You may know. It has to do with this step from here to here. If you work this backwards to get it into this form to where you can type it into the graphing calculator, or I could ask it like this: is this final equation actually the same thing as this equation? No, it's not. Here's the difference. This is not a function. It's a circle. This is a function. Because if you actually wanted to graph this circle working backwards, to get rid of the square, when you square rooted the other side, you would have to put what with it? Thank you. And there's no plus or minus here. This is a circle, but it's only the top part of the circle. It's only the positive part. That's what they're asking you to graph. Pretty much that's a semicircle. It's half circle. A semicircle is a function. As soon as you do this, not a function. Look here. This is also a circle. Can you tell me what's going to be true about the circle? Since you have the negative here. It is a function still, because it's not plus or minus. You're not graphing the whole circle. You're graphing the bottom. Okay? So if you want to, guys, move the square over, move the x squared over. This is a circle with a radius of 2. If you don't remember, circles look like this. X squared plus y squared equals r squared. Moving the square over, moving the x squared over gives you x squared plus y squared equals 4. But again, you're graphing just the bottom part of it. So the radius would be 2. It's going to look like this with a radius of 2. Okay. So your domain, what can I plug in? Let's just do it with our graphing calculator here. If you don't have a graphing calculator at home, I recommend Desmos, D-E-S-M-O-S. If you just have your computer and there's no way to get you a graphing calculator, this is a very good program. Negative root. It actually gives you better graphs than the graphing calculator we use. Y equals the negative square root of, what was it, x squared minus 4? 4 minus x squared, thank you. A 4 minus, and it actually graphs it as you type it in. X squared. There you go. There's your graph. And see, that one looks, to me, that one just looks better. You can zoom in, zoom out. Domain. Your graph starts at -2 and it goes to +2. That's your x. How far left does your graph go? How far right does your graph go? Your domain is -2 to +2. Your range would be how low your graph goes and how high your graph goes. Your range would be from -2 to 0. Could I have obtained that information from knowing it's a half circle with a radius of 2? Yes, you could have. A little bit more. I think that's enough graphing stating the domain range. Let's do piecewise functions and then we'll stop for the day. Maybe. A piecewise function. You know what? I'm actually going to use that same graphing calculator program. We're asked to graph this function, f of x. F of x is actually equal to 2 different things. We deal with piecewise function most every day in this way. Here's your real life example of a piecewise function. Your cell phone, you're usually allowed, if you have data plans, you're allowed so many gigs, right? Most people in here, 3, 4 gig. What happens when you go over 3, 4 gig? Bad things. Your parents get mad at you, just upset, just bad things happen. That's a piecewise function, not the bad things happening. The actual gig plan there is a piecewise function for this reason. You're following one set price for anything that you use between 0 and, let's just say you got 3 gigs. So anything that you use between 0 and 3 gigs, here's the price. Anything over 3 gigs, here's the price. And we don't even want to touch that, okay? You go over your data plan, they sock it to you. So that's what a piecewise function is you actually have, which most of the time if you were doing a function like that, it would be, instead of f of x, it would be like c of x, where c is your cost. Your input would be gigs. How many gigs of data did I actually use? If, and again, here's how they would write it. For all things that you input between 0 and 3, this would be your cost. For all things greater than 3, and you would have a different function. So that's what a piecewise function looks like. They say, okay, to calculate price, it really depends on what you're putting in. Guys, this over here would be, therefore, your domain, would it not? For all domain values from here to here, or you could actually write that as an interval. That'd be from 0 to 3 inclusive, or this would be from 3. That's just scary putting an infinity sign on this problem. That'd be really bad. From anything from 3 to infinity, this would be your cost. So you might have 2 different functions to plug into, all depending on what you're putting in. That's all this is saying. This function, this f of x, is equal to this, as long as your x value is between -2 and +2. Anything above 2, it jumps here. That's it. That's all a piecewise function is. So if I ask you for the domain, which they do here, state the domain and range. If I ask you for the, let's do domain just by looking at this. What are some things I can't plug in? Anybody know? Give me one number that I cannot plug into this function. You plug in 3, but you're on the right track, because 3 is greater than 2. I can plug in 3, but I just have to plug it in here, because it's greater than 2. -3. There is nowhere to plug in -3, because it says use this if x is between negative and +2. Well, what about if x is less than that? What if x is -3? There's nowhere to plug it in. Therefore, you can't plug it in. So what would my domain be on this problem? Let's go ahead and again knock that out. My domain would be all the things from -2, because I can plug in -2, up to 2, and I can actually plug in things greater than 2. I just plug it in down here. So I can plug in all things from -2 into infinity. That's your domain. Now, how would I graph that on my graphing calculator? I'm going to do it on Desmos here. X squared minus 4 and x minus 2. So here's my 2 graphs. We already knew x squared was going to be a parabola. We already knew x minus 2, hopefully we knew, was going to be a line, y-intercept -2, slope 1. If we type this into our graphing calculator, it's not going to follow these domain restrictions. It's going to give me the whole graphs. Guys, I didn't want to graph this whole x squared minus 4. I only wanted to graph this portion of it. So here's what I would do. Is if you're going to use a graphing calculator, just know that the graph that you're going to get, you're not going to use all of it. You're only going to graph x squared minus 4 from here to here. So you've got just this part. You're only going to graph x minus 2 from 2 on. So you've only got this part. Whoop. I nearly put an arrow there. Let me explain why I didn't put an arrow there. The black part would be the graph of this f of x. Okay, you're only graphing x squared minus 4 from -2 to +2, and then from there on, you're going to graph x minus 2, which will be here to here. And I'll do this by hand in just a second just to show you, and then this will be the last problem we have time for. I put an arrow on this end. because we could plug in things greater than 5. This only runs from 2 up to 5. Guys, it says all values greater than 2. Can I plug in 6? Yeah. So that's the reason I put the arrow here. The reason I did not put an arrow here, x values for this portion of the graph starts at -2. It doesn't continue. Okay? If you put an arrow, you're saying that this thing keeps going. It does not. It goes from -2 to +2. This one goes from 2 to infinity. That one does keep going. If I ask you to graph this same thing by hand, here's how I do it. Let me throw this away. Graph paper. Here we go. I get myself an origin. Let's do it in red so we can see it. Here's my origin. And when you graph by hand, that's all you have to do for me. There's your 0, 0, and then we're just going to count. I'm plugging in things from -2 to +2 into this graph, so just do that. Plug in -2, and again, I'm not going to make a t-table. You can if you want to. I'm not going to. Plug in -2, plug in -1, plug in 0, plug in 1, plug in 2. Here we go. Plug in -2, you get 4 minus 4, which is 0. There that is. Plug in -1, you get 1 minus 4, which is -3. There. Plug in 0, you get -4. Plug in +1, you get -3. Plug in 2, you get 0. Don't keep going. If you still don't like the looks of your graph, don't go outside of those numbers. We're only plugging in -2 to +2. If you want more numbers, plug in decimals. -half, -1.5. Plug in stuff like that. Just don't go outside of that domain, because that's all you're asked to graph. Then you say, okay, pick up here. Now do this. Always plug in this endpoint. But don't, if it's less than or greater than, don't include it. Open circle. That makes sense. You will plug it in. That'll tell you where to start, but do not include it. Because you're only allowed to plug in things greater than 2 into this. So if you're going to plug in 2, that's where it's going to start. Because even though you can't plug in 2, it says all things greater than 2. Could I plug in 2.000000001? Yeah, that's pretty much 2, but you can't plug it in. Here's the second part of your graph. I'll do it in black. 2 minus 2 is 0. 3 minus 2 is 1. 4 minus 2 is 2. There's 4, 2. 5 minus 2 is 3. 6 minus 2 is 4. And that one goes on forever. And even though I did not include it in that portion of the graph, look, it was included in the second portion, or the first portion, so it is part of your graph. There's what your graph looks like. You have a parabola for part of it, and then you have a line for the rest of it. That is a piecewise function.